Okay, our next topic, that is a topic 3 now, will be on binomial expansion. Okay, I believe we've learned this in the class. I just want to remind us some few things about binomial expansion, then we see what we can see in the past question. First of all, I would like to talk about the theory. The theorem that guides this expansion. Okay. This thing came as a result of if we have a plus b all raised power n, or we have a minus b all raised power n. For us to be able to expand expressions like this, that brought about this binomial expansion. So we will start with the theory. The theory says that the a will start from n and continue reducing till it gets to 0, while b will start from 0 and continue increasing till it gets to n. Let me take one example. If I have a plus b all raised power n, this becomes a raised power n, b raised power 0, plus a raised power n minus 1, b raised power 1, plus a raised power n minus 2, b raised power 2, and this will continue till we have plus a raised power 0, b raised power n. And that is what the theory is all about. So like I said, the theory starts from a raised power n. A will start from the power of n and continue reducing till it gets to 0, while b will start from the power of 0 and continue increasing till it gets to the power of n. The same thing applies to this, it's just the sign so that we can take note of that. We have a minus b. A minus b means, a raised power n, then minus b raised power 0. Take note of that. Minus b raised power 0 plus a n minus 1, then minus b raised power 1 plus a n minus 2, then minus b raised power 2. And this will continue to have plus a raised power 0, then minus b raised power n. Now, I must let us understand that according to the school syllabus, the value of n that you should learn for this coming exam should be a whole number. So that means you are not asked to go and learn something like this. No. They say let the value of n be whole number. So don't look for where n is raised power half. There is solution to those things also, but since you are preparing for the school exam, you have to follow what the school syllabus says. So the school syllabus says that the power of n should be whole number and not a fraction. So note that so that you limit what you are reading. Time no day. So don't read rubbish, okay? So this is the theory. Then what we are trying to say that these things have been expanded using this theory, okay? Then the next thing we are supposed to have here is the coefficient. Remember, each of these things are called terms. So this is the first term, this second term, and so on. So each of these terms should be backed up with what we call coefficients. So to bring in coefficient into this term, we are going to talk about Pascal's triangle first. We're going to talk about Pascal's triangle. Pascal. We're going to talk about Pascal's triangle. Pascal's triangle's work here is to bring in coefficient to each term. So you just learn how to draw out the Pascal triangle. I'm going to draw from 0 to 4. Let me draw from 0 to 4. I have 1, then I have 1, 1, then I have 1, 2, 1, then I have 1, 3, 3, 1, then I have 1, 4, 6, 4, 1. I have 1, 5, 10, 10, 5, 1. And that can continue as many as I remember. I know you still remember. So this is when n is equals to 0. The whole of this line is n equals to 1. The whole of this line is n equals to 2. The whole of this line is n equals to 3. The whole of this line is n equals to 4. And the whole of this line is n equals to 5. So let me put up a simple example. Since I have the Pascal, if I have x plus y raised to power 3, and I'm asked to expand completely, what I'm going to be having there is, first of all, I'll apply the theory. So I have x raised to power 3, y raised to power 0, plus x raised to power 2, y raised to power 1, plus x raised to power 3, y raised to power 0, 1, 2, plus x raised to power 3, 2, this should be 1, 0, y raised to power 3. You see that I'm through with the application of the theory that says that A will start from n and end at 0, while B will start from 0 and end at n. So you see that A, which is my x here, starts from 3. It has ended at 0, and my y started from 0 and it has ended at 3. The next thing is to fix in their coefficient. So the power of n here is 3. So I'm going to take this line just to put this line directly. So I'm going to be having this for the, for n equals to first term, second term, third term, fourth term. First term, second term, third term, fourth term. And this is complete expansion. What is left here now is simplification. When y raised to power 0 is 1. So 1 times x cubed times 1 will give me x cubed plus 3x squared y plus 3xy squared plus 1 times this will give me this. And this is my final answer. So if I'm asked to expand completely, this is what I'm going to have. And this is what we call the Pascal's triangle. Okay, so Pascal's triangle is used to add coefficient to each of the terms. Why? First of all, what you're going to bring out is the theory. Then after the theory, you add the Pascal's triangle. And if you can do these two things, then you know that you are good to go when it comes to binomial theorem. Now, another way you can add coefficient to the term is by using combination method, which your calculator can actually help you out. You know, examination is also about speed. So however you can gain speed, or however you can get help to gain speed, you should do it. Now, if I expand x plus y all raised to power 3, I'm going to be having, according to the theory first, this is the theory first. Then to add coefficient, I don't want to use Pascal, I use combination. So I have n combinate 0, n combinate 1, n combinate 2, n combinate 3. Remember, I started with n combinate 0, n combinate 1, n combinate 2, n combinate 3. But my n here is 3. So I have 3 over combinate 0, 3 combinate 1, 3 combinate 2, 3 combinate 3. So to get 3 combinate 0, you can get that with your calculator. If you look at your calculator, please look at the calculator we're making use of here. This is FX991ES Pro. This is a calculator we are making use of here. So 3 combinate 0. So I have 3. You press 3, you press shift. You press the divide key as if you want to do division. On the divide key, you see n combinate r. Press the divide key. You have on your screen 3C, then 3 combinate 0. So what you have is 3C0. 3C0. That will be what will appear on your screen. You press equals to it, will give you 1. That means the whole of this is 1. Then we have x cubed. I have y0 plus 3 combinate 1. So I have 3 shift divide 3. 1, sorry. So I have 3C1, which will give me 3x squared y1 plus 3 combinate 2. 3 divide C2 will give me 3 also, xy squared plus 3 combined 3 is 1, x naught, y 3. So at that point, 1 times this will give me x cubed. This will give me 3x squared y. This will give me 3xy squared. And this will give me y cubed. You see that in the absence of Pascal's triangle, we can also get the coefficient of the terms using combination method. And these are the two methods I've shown us on the board. So that is, I've explained the theorem, I've explained the Pascal's triangle. So let's see some examples. First of all, we'll take a work example from plasma tutorial mock examination. He gave us this expression. He said the question has it that 2 minus x over 3 all raised to power 10. He now said we should find the 7th term, coefficient of the 7th term, coefficient of the 7th term in this expansion. It means if you finish expanding this, get this, go to the 7th term, tell us the coefficient. So we are going to be using solution now. We're going to be using r plus 1 th equals to n combined r, a n minus r, b raised power r. So finding the parameters given to me here. Here I have that my n is equals to 10. I have that my a is equals to 2. I have that my b is equals to minus x over 3. Then I need to get my r. Now, from that, knowing fully well that r plus 1 it will give me is, we are talking about the 7th term here now. Th, that means r plus 1 is 7. Th. So what plus 1 will give me 7? That means r is equals to 6. Because 6 plus 1 will give me 7. So it is r, the value of r there is 6. So I have r to be 6 here. So all I need to do is to put these values into the question. So I'm going to be having 10 combined 6. 2 raised to power 10 minus 6 is 4. Then minus x over 3 raised to power 6. I'd like us to look at the way I'm going to simplify this. And this becomes 10 combined 6 times 2 raised to power 4 times, this is the same thing as x raised to power 6 times minus 1 over 3 all raised to power 6. Then this is same thing as 10 combined 6 times 2 raised to power 4 times x raised to power 6 times minus 1 all raised to power 6, 3 all raised to power 6. Now, trying to put this expression in a better way, I get hold of my calculator. Then 10 combined 6 will give me 210. I have 210 here times 2 raised to power 4. 2 raised to power 4 is 16. I have 16 here times x raised to power 6 times minus 1 raised to power 6 will still give me minus 1. Then I have 3 raised to power 6 will give me 729. Minus 1 raised to power 6 will give me plus 1, sorry. That is still 1. Will give me 1, positive 1. So here I'm going to be having 210 times 16, which will give me 3360 x raised to power 6 over 729. Hence, this is the coefficient of the 7th term. And that is what the question was asking me. So this is a coefficient of the 7th term in the expansion of this. I believe God gives us a good understanding to follow up what we are doing. So we are going to look at questions from the past question this time around to see how we can also derive this point of binomial theorem home. The first question I'm going to be having there says is 2020 question number 10. 2020 question number 10 it has something like this. If you look at your book properly, it has something like this. And it now says that I should find the coefficient of x cubed in the expansion of this. The coefficient of x cubed in the expansion of this. So my solution still follows the same way. I'm going to be having r plus 1 th equals to n combinate r, a n minus r, b raised power r. So bringing out my parameters, I have that n is equals to 5, a is equals to 1, b is equals to minus x over 2, okay? R, we don't know. Assuming they gave us the position of the term, or they mentioned like 7th term, 5th term, it will help us to get the value of R. But this time, they didn't mention the term. They just said we should find the coefficient of the term, the unknown term that is going to have x cubed. So first of all, I'm going to look for the value of R. See what I'm going to do there. I'll fix everything here. So I have 5 combinate R, 1 raised to power 5 minus r, then minus x over 2 raised to power r. So what I'm actually going to be looking for here is to get out the factor of x. That means this one has no x, I don't have any problem with it. This one has no x, I don't have any problem with it. But this one has x, so let me simplify this further. Do you know that minus x over 2 all raised power r is the same thing as x raised power r times minus 1 over 2 all raised power r. This times this times this will give you this. Why? This times 1 under it will give you this. So at this point now, if you watch, this one self no get x again. Therefore, I have my x raised power r as the only factor of x I can get from here. Then I will equate it to what they are asking me, x raised power 3. From here, I simplify for x. Then I equate it to x raised power 3. Therefore, at this point, x raised power r equals to x raised power 3. Therefore, r is equals to what? 3. The bases are x. Then if the power is here is r, here is 3. That means if this is equals to this, if this is equals to this, that means x is equals to x, r is equals to 3. So I've got the value of my r to be what here now? 3. Having gotten the value of my r, I think my work is excuse me, more than half done. So I put it, I have 5 combinate 3, 1 raised to power 5 minus 3 is 2. Then 1 over 2x raised to power r, which is 3. So if I simplify this, I will have what I'm looking for. So 5 combinate 3 from my calculator, I have it 5 combinate 3 is 10. Here is 10 times 1 raised to power 3 is still 1 times this. Remember that this is the same thing as writing x raised to power 3, the carry minus, okay. This now, bring it down here. It's like this. This is like this. So I have x raised to power 3 times minus 1 over 2 raised to power 3. So I have 10 times 1 times x raised to power 3 times minus 1 raised to power 3 over 2 raised to power 3. Okay, so I have 10 times 1 times x raised to power 3. This is still going to be minus 1 over 2 raised to power 3 is 8. 2 times 2, 4. 4 times 2, 8. So I have 10 times 1 is 10. This will give me minus 10x cubed over 8. 2 can go here. So I have minus 5 over 2 here is 4. Because 5 times 2, 5 times 2 is 10. Sorry, we're using 2. 5 here. 2 times 5 is 10. 2 times 4 is 8. So 4, then x cubed. Hence, the coefficient of x raised to power 3 in that expansion is minus 5 over 4. And that is question number 10. Minus 5 over 4, option B. So I believe that was very clear. If you can replay the video over and over again to get the main point here is how to simplify this. How to simplify this to get the value of r. And when you have gotten the value of r, you put that whatever you have simplified this now, so that you can be able to get the final expression for that. Okay. The next question will be the same 2020, 2021. Question number 4, section B. Question number 4, section B. Question number 4, section B. A very simple question in question number 4, section B. It says we should expand completely y plus x all raised to power 5. I believe this was done in the example when we started, so I think you should look up this from there. So let's quickly go to 2021/2022 question. 2021/2022 question number 8. Let's see that. So I'm going to be having 2021/20 question number 8 here says the binomial expression for a plus b raised to power n is, you can see that thing is summation. That answer should be option D. Option D. So let's leave that one. We go to question 9 of it. Using Pascal's triangle, find the coefficient of x plus 5. X plus y all raised to power 5. Using Pascal's triangle. When you finish using Pascal's triangle to expand this, the coefficient of the terms, just write them out. That's what they mean. So you find n raised to power Pascal's triangle up to n equals to 5. Or you can use combination method and just bring out the coefficients. Or the coefficient like that. I think that is going to solve for that. Okay. You can see the coefficients, like you see the options. All the coefficients from first term to the last term. Bring out the coefficient of the first term, bring out the coefficient of the second term, bring out the coefficient of the third term, the fourth term, the fifth term, the sixth term, line it up, and you will see your answer in the OBJ section. Let's go to the last year, 2022/2023. Question number 27. Question number 27. Okay. Question number 27. The value of the term independent. Okay. Look at this now. They gave us x minus 2 over 3x all raised to power 8. And they say we should find the value of the term independent of x. The value of the term independent of x. You see, when they say a value of the term independent of x, it's just that they are asking to find the coefficient of x raised to power 0. That's all. So you're going to be solving it like this other one we solved. But in this case, you can turn the question to coefficient of x raised to power 0, since it's the term independent of x. And when x is raised to power 0, it gives you 1, which is independent of x. So I'm going to be using r plus 1 equals to n combined r, a n minus r, b r. So I have my n here to be 8, my a to be x, my b to be minus 2 over 3x, then my r, I don't know. My r, I don't know because they didn't mention a term for me. So using r plus 1 term is equals to n combined r, a n minus r, b r. So I'm going to fill in to get the value of my, I have 8 combined r, x raised to power 8 minus r. Then I have minus 2 over 3x raised to power r. I need to simplify this guy well. If I have minus 2 over 3x raised to power r, is the same thing as minus 2 over 3 raised to power r times 1 over x raised to power r, which is also the same thing as minus 2 over 3 raised to power r times x raised to power minus r. So here, this is the only factor of x here. So the factors of x I'm seeing in this are 1 and this. So I have x 8 minus r times x raised to power minus r will be equals to x raised to power 0. Why is it equals to x raised to power 0? Because we are looking for the constant term, so we are going to equate it to x raised to power 0. So we have here, these bases are the same, so we add the powers. We have 8 minus r plus minus r equals to 0. We have 8 minus r plus times minus is minus r equals to 0. Minus r, 8 minus 2r equals to 0. So that 8 is equals to 2r. Then r becomes 8 over 2, which will give me 4. So the value of my r becomes 4. I want you to repeat this video and see what I have done here. Remember, I picked it from here. This guy already have x, but I want to find the x here. 2 over 3x is the same thing as 2 over 3 times 1 over x. Then the arrow belongs to both things. 2 over 3 minus 2 over 3 raised to power arrow times times 1 over x. That is, if you do this times this, will give you minus 2. This times this give you 3x. Then in this case now, this one does not have x, it will go. This one is the one that has x. So I have x raised to power, let me write it very well. X raised to power minus r. Hope you understand that. X raised to power minus r. That is 1 over x is same thing as x raised to power minus r. This and this are the same. So we have only two persons that have factors of x. We have this and we have this. This one was gotten from here, while this one is here gotten from this one. So I brought this and this. I brought them out. This times this. Then equate it to x raised to power 0. Why? Because we are working on constant term or a term independent of x. So you always equate it to x raised to power 0. So at the end of the day, we got the value of r to be 4. So if we have got the value of r to be 4, then we impute it and we have 8 combined 4. Then my 8 combined 4. Then, okay, I think I've lost the question there. 8 combined 4. We're talking of question number 27. Okay, 8 combined 4. A is times x raised to power 8 minus 4 times minus 2 over 3x raised to power 4. So we have 8 combined 4. 8 minus 4 is 4. You know, this is the same thing as minus 2 over 3 all raised to power 4 times 1 over x all raised to power 4. So pushing up that, I have 8 combined 4. This is 70 times x raised to power 4 times minus 2 raised to power 4. 2 raised to power 4 is 16. 3 raised to power 4 is 81 times 1 raised to power 4 is 1. Then x raised to power 4. Okay. So 70 times 16, 1120. This times this times this times will give me 1120 x raised to power 4 over 81 x raised to power 4. Are you following that? See, x raised to power 4 will cancel x raised to power 4, leaving with 1120 over 81. Final answer. This is the term independent of x. You see that in this final answer now, there is no x. What if they further ask us to find which term did this thing happen? Remember, to find the position of the term, it is r plus 1. So if our value of r is what? 4. So 4 plus 1 will give us 5th term. This thing happened in the 5th term. So if you like, take that question, Keep expanding it. After expanding it, look at the fifth term. You will see this. You will see that the fifth term will be independent of x. So, like I said, rewind this video over and over again so that you can get what we have been doing here well. I'm going to end with this last example. If you are given something like this, 1.02 all raised power 3, which will expand. In this case, my A is 1, my B is 0.02, and my N is 3. So the same thing, 1 raised to power 3. Let me start with the combination. 3 combinate 0, 1 raised to power 3, 0.02 raised to power 0 plus 3 combinate 1, 1 raised to power 2, 0.02 raised to power 1 plus 3 combinate 2, 1 raised to power 1, 0.02 raised to power 2, then plus 3 combinate 3, 1 raised to power 0, then 0.02 raised to power what? 3. So you see that we have finished expanding. Now, if you follow this step and simplify it further, you will see the final answer of this. And it will tally with what the calculator is supposed to give you. If you press 1.02 all raised to power 3 and you solve it, you'll still be getting the final answer as 1.061208. If you solve this out, you are going to get this. And that is exactly what the calculator also has given to us. But then, in the exam, they may not ask you to expand completely. They can say, what is the coefficient of this? What is the coefficient of the third term in the expansion of this? What is the coefficient of the third term in the expansion of this? What is the coefficient of the third term in the expansion of this? So, in the expansion of this is a third term. You simplify, you tell them. So, or you can use, if they ask me, what's the coefficient of the third term in the expansion of this? Since I've mentioned the third term, I can also use r plus 1 is equals to 3. So r equals to 2. So I can use n combinate r, a n minus r, b raised to power r. So the third term now will now be 3 combinate r, which is 2. Then my a is 1. 3 minus 2. 3 minus 2 will give me 1. Are you seeing that I'm forming all this? Then my r, b is 0.02 raised to power r is 2. Do you see that what I have got here is the same thing of what is here? And that is the third term. 1, 2, 3. Can you see the beauty of what we have been doing? The beauty of it. So whichever one you want to use. And this brings us to the end of binomial theory. So in the next class, we're also going to be entering the next topic. We have done 3 topics. Now we're going to be entering the next topic.